Saturn's largest satellite is located approximately 10 AU from the Sun, outside our star's habitable zone. Its orbit lies well beyond Saturn's rings, at a distance of about 1.2 million km from the planet's center. Titan follows a nearly circular trajectory, completing an orbit around Saturn in less than 16 Earth days. With a diameter of 5,152 kilometers, Titan is 5.6% larger than Mercury, but its mass is relatively small at 1.35 x 10^23 kilograms, which is about 40% of Mercury's mass. Titan's average density is approximately one-third that of Earth, indicating a different chemical composition. Titan is believed to have a massive core at its center, measuring approximately 3,400 kilometers in diameter and composed of various silicon compounds. Surrounding the core is a thick layer of densely packed ice, forming the base of a deep liquid ocean. This ocean contains high concentrations of dissolved ammonia, methane, and caustic salts, resulting in a freezing point lower than that of water. As a result, Titan's subsurface ocean remains in a liquid state despite sub-zero temperatures. The ocean is enveloped by a thick, approximately 100 kilometers crust consisting of a mixture of water ice and methane hydrate. The tidal forces exerted by Saturn cause continuous deformation, leading to extensive rifts and fractures on the surface. These conditions give rise to cryovolcanoes, which erupt significant amounts of methane, ammonia, and water onto Titan's surface. Methane plays a role in Titan's atmosphere similar to that of water vapor on Earth. The satellite's average surface temperature is around 94 K or minus 179 degrees Celsius, slightly below its boiling point. Natural variations in temperature cause hydrocarbon vapors to condense and form methane seas, lakes, and rivers. Titan's atmosphere is primarily composed of nitrogen, making up about 98.4% of its volume, with methane accounting for approximately 1.6%. The extremely low temperatures on Titan cause the atmosphere to remain condensed near its surface, resulting in a pressure 1.5 times that of Earth. Most of Titan's surface is permanently hidden from view due to multi-layered clouds and an orange-yellow haze known as tholin. This haze is formed by tiny droplets of liquid methane and dissolved organic matter, giving Titan its distinct appearance. It absorbs and scatters visible light while transmitting infrared light. This unique property creates an anti-greenhouse effect, cooling the surface by around 10 degrees Celsius. Despite the challenges posed by this environment, the Cassini orbiter's infrared cameras have partially mapped Titan's surface. Although not as accurate as desired, this mapping has revealed notable features. One such feature is the area known as Aslan, slightly south of Titan's equator, characterized by contrasting spots. One prominent spot is Dune Mons, a mountain towering 1.5 kilometers above the surrounding plains, with a diameter of up to 60 kilometers. Its summits have craters, and its slopes show signs of recent turbulent flows, suggesting it may be an active cryovolcano. To the northeast of Dune Mons lies Sotra Patera, Titan's deepest depression, extending about 30 kilometers in length and located 2 kilometers below the adjacent plains. This depression is believed to be the mouth of a massive cryovolcano and is part of the same tectonic structure as Dune Mons. North of Dune Mons lies Mohini Fluctus, an expansive area covered by the ejections from Dune Mons. This region spans approximately 180 kilometers and varies in width, featuring frozen material and sand dunes composed of a mixture of methane and water ice. Continuing our flight, we will pass over the dark area called Fensel. In the northwestern part of Titan, the largest impact crater called Minerva can be found. It has a diameter of 440 kilometers, making it 3 times larger than any other crater on the Moon. Minerva is estimated to be between 300 million and 1.2 billion years old, making it the oldest and largest remaining crater on Titan. Despite significant erosion and tectonic activity, its immense size ensures its visibility. Minerva exhibits a well-defined internal structure, consisting of a central flat plain surrounded by a ring of hills. This light-colored region spans approximately 200 kilometers in diameter and is surrounded by a 50 kilometers wide strip of dark plains referred to as a moat. Beyond the moat lies a ring of low mountains, forming the outer boundary of the crater. In the southern range of Titan, there is the highest peak, reaching 3,337 meters. Looking west from the summit, one would see the vast dark plain known as Shangri-La. It is believed that this area was once flooded with liquid methane, possibly persisting beneath the topsoil similar to underground water on Earth. While most of the region has a flat terrain below average elevation, there are lighter hills that may have been islands in the past. West of Shangri-La is the bright Adiri upland area, standing out against the surrounding dark regions. This extensive region, spanning up to 2,500 kilometers, contains numerous drainage canals and caves, likely formed by flows of liquid hydrocarbons. Further west lies the vast dark lowland area of Belet, while to the east, near the border of Shangri-La, is the Huygens landing site. Equipped with various instruments, Huygens measured air currents, electrical conductivity, temperature, and atmospheric composition. It captured photographs, made audio recordings, and examined the ground upon landing. The images revealed a flat plain scattered with rounded rocks that indicated the impact of powerful fluid currents. The probe also used a special drill to collect samples from the surface, measuring density, texture, and composition. The Huygens probe discovered that a thin layer of small rounded pebbles rested on a relatively soft and dense substrate, resembling wet sand or dense snow. Methane gas was released during the drilling process, indicating the presence of liquid hydrocarbons in the ground at the landing site. The probe successfully transmitted approximately 500 megabytes of data, including 350 photographs. In addition to these findings, further analysis unveiled unique attributes of Titan's atmosphere. At an altitude of around 80 kilometers, there exists a layer of near-complete stillness, seemingly dividing Titan's atmosphere into two distinct parts. Titan's atmosphere exhibits a curious phenomenon, an intermediate layer where neither upper air currents nor surface winds reach. The cause of this phenomenon remains unknown. Titan also possesses two ionospheres. The first, located around 1,200 kilometers altitude, is formed by stellar wind streams and cosmic radiation. The second ionosphere, located around 60 kilometers altitude, has a disputed origin. Krakenmeer is Titan's largest hydrocarbon reservoir, covering an area of about 400,000 square kilometers. Its depth exceeds 200 meters, but the exact measurement is unknown due to high viscosity. Ligeia Mare, located to the north, is a significant natural basin near Titan's pole. It is approximately 3 times larger than Earth's Lake Baikal, with a diameter of 500 kilometers.